Hello and welcome to the second lecture in chapter 22 in our comprehensive course on data science, machine learning and artificial intelligence. Now, here we start with this topic, encoding categorical variables. Now, there are many techniques for encoding. One is called one-hot encoding, another is called label encoding. Apart from them, there are also techniques like target encoding, and there are some specialized techniques also. But we will satisfy ourselves with only two of the encoding techniques because 99.99% of your problems would be solved by these two. And second thing is that even if you want to use target encoding, the basic concept is same. You just have to use different tool or different library or different line of code. Okay. Now, here this is just again importing the California housing dataset, and we again set this display.max underscore columns equals none. So that means how many columns, maximum columns to be displayed, then there is no limit, none limit, or that means display as many columns as are there in the data set. Now, in this topic, you will see the importance of setting that option, because among the two encoding techniques, that is the one-hot encoding and the label encoding, one-hot encoding has one limitation, that it increases the dimension of the data set disproportionately or to a very large amount, that is. So that means that by one-hot encoding, if it is not appropriately applied, then in that case, you will get the resulting data frame which is having several or so large number of columns that it will not be able to display them in the Jupyter environment unless you set this option. Okay. Now load the data set, fetch California housing and convert it into pandas data frame and display the header row. That much we have already done earlier also. So these are the original columns. Data types, if you do, then all are floating point. Now as such, that means for this data frame, there is absolutely no need to do encoding, because when encoding comes into picture is when there are categorical variables. Okay. Categorical variables can be, one example of them is ordinal variables, or other example also can be there in which there is no implicit order implied. For example, suppose there is one column, here there is no such column, but suppose there is one column gender in which it is written male and female. So there are two categories. Okay. Similarly, there is one another column age, and in which the age is not specified in year, but instead it is specified in bins. So that is maybe 15 to 25, then 25 to 35, 35 to 45, 45 to 55, 55 to 65, and so on. So this each bin that becomes one category at that time. Okay. Similarly, ordinal variable, there are certain applications where there is inherent some hierarchy involved or some gradation involved. So in male and female, there is no hierarchy involved, right? You cannot say that male is superior than the female or female is superior than the male in any way. Both are just different categories, that's all. But for example, if it is employee designation as one column, and in the designation it is written that junior clerk, junior officer, senior officer, junior manager, senior manager, then vice president, president of the company, and CEO. Now you can see that there is inherent hierarchy here. That means that as one takes different categories in the order which I spoke, then you get higher and higher position in the organization, right? So that is that type of variable, they are called ordinal. Similarly, suppose you ask someone's feedback about your company's product, or you ask the viewer's feedback about your company's website, and at that time the customer survey is done in that manner that it asks the user to enter answer from very poor, average, good, very good, and excellent. Now here also you can see that there is inherent hierarchy. So as you go from very poor to excellent, then your product definitely goes on becoming better and better. So that is one thing. Another similar example may be the performance rating of the employees, right? So you can say that again it is very poor and all that kind of things. But these kind of variables, they are called ordinal variables, but they are also categorical variables. Now whenever that kind of variables are there, then you need to convert them into encoding, because a computer does not understand this type of words, male or female, right? A computer, so you will have to convert, maybe male is equal to 1 and female is equal to 0. Then it is converted into numbers. Or similarly, a computer does not understand, for example, that very poor, then average, then good, and then very good. So here you can write them on a scale. Maybe very poor is equal to or you can write average, very good, and say still one more, excellent. Now you can write them on a scale like this, that very poor is equal to suppose -3, then poor is equal to -2, because all negative opinions, then average is equal to say -1, because suppose it is company's policy that even if customer just says average, it is not acceptable to the management. Only acceptable answers are good, very good. So good is say 0, or maybe average is okay. So good is 0. Then 0 does not mean it is some kind of zero number. Okay, it is just a category. Then 1 is very good, and excellent is 2. So you get this kind of a scale, and you convert your strings, very poor, poor. These are all words. Computer is not going to understand them, or no machine learning algorithm will also understand them. Algorithm will need numbers. So at that time, you can write them in this kind of coding. Okay. Now, if the coding method inherently uses 1, 0, etc., then most of the time it is one hot encoding. While if coding method uses this kind of some labels, then it is called label encoding. That is numbers other than 1, 0, right? But let us see in each in detail, because then only things become clear. Now, as I said, currently I have this as a data frame, and all variables are themselves right from the beginning numbers, floating point. So how will I display the encoding technique? So I will have to convert any one variable into the categorical variable first, just for the sake of demonstration, and then we will again convert it back to numbers. Okay. Remember, every time it is not required. I gave many examples just now, in which there will be columns which are inherently right from the beginning categorical columns, right? So you don't have to do this process, converting a numeric column into categorical column and then convert it back to numeric column. That looks like a reverse kind of thing, but that is here because this data set unfortunately has no categorical column built in, right? So then this is, I'm taking latitude column. Those who are having the printed notes of this, they will find that there I have taken example of the median income instead of latitude, but later on I found that better would be to convert into latitude. So that is okay. Median income also, for the sake of demonstration, it works perfectly well. So I'm taking latitude column and using this command pd.categorical, okay, and in bracket I am writing df.latitude. So that will be converting this latitude column, which is at present just a number, into category, right? And then we check it whether it is converted or not. So by d types. So when you see now the data types of all other columns are float, longitude is also still float, but the latitude is now categorical column. Okay. Sometimes categorical columns will also be displayed as object obj. So then also it is fine. You have to convert this. Now we can demonstrate our encoding technique. Okay. Now for encoding, you have to first see this. So this step is always important. Which column you are encoding? That is df.latitude. Okay. There are two ways of writing. One is this way, df, and then in quotes latitude. This is also one way of writing, right? And another way of writing is df.latitude. Both will work in the same manner. So how many categories are there? How many unique values are there? So this n unique means number of unique categories. In the latitude, how many unique categories are there? So if you find that out of total 12,000 or 20,000, how many rows were there? If you remember, then it was 20,640 rows were there. So it is a big data set. But among them, most of the time latitude, etc., these are not changing so frequently, and therefore latitude for many rows will be same value, and therefore how many unique values are there for latitude? Then out of 20,000 rows, 862 unique values are there. Now why we find this is because this will help us to decide which encoding technique to use. Now if the number of unique categories are around 5, or maybe just in some extreme cases up to 10, then you can use one hot encoding. But if such large number of categories are there, 862, then we don't use one hot encoding, we use label encoding. Why? That will become clear just now. But here our purpose is just to explain one hot encoding. So therefore we do one hot encoding, though we are knowing that for such large number of categories, 862 categories, for that kind of column, it is not advisable to do one hot encoding, right? So in that type of case, we will use one hot encoding just for the sake of demo. That will show you why it is not wise to do one hot encoding. Now for one hot encoding, remember there is no keyword of writing that encode, okay, or that is one hot encode like that. While in label encoding, there will be a label encoder object first you will have to initialize, for which you will have to import this label encoder library. So that is easier to remember. While for one hot encoding, there is no such one hot encoder library and from which you will initialize one hot encoder object and nothing. You just have to write one single line. That's all. pd.getDummies, and in bracket you have to write which data frame, and in that data frame you have to include all columns which you want to encode. So here I have only one categorical column, latitude. So I am including only one. But suppose I have 5 categorical columns in my data set, then I will write each of them in this here, then comma, another column in quotes, then comma, another column in quotes, then comma, another column in quotes, and so on. So this square bracket, that is actually the comma separated list of columns which you want to encode. Now here there is only one column, so I am writing latitude. So data frame and the list of columns which you want to encode, that is the two arguments which you must pass to the pd.get_dummies, right? And just a single line will automatically convert this into one hot encoded column, numerical column. Let us see what it generates in this case, because this latitude had so many categories. Okay, so that is why it would be difficult to understand. So instead I am giving first one simpler example. So let us open our notepad, that is that, and let us take one simple example. So as a simpler example, suppose there are several columns in the data frame, of which one column is this, that is gender, right? And there are only two categories. Here there are 862 categories, but here there are only two categories, and they are male, female, and these are top 5 rows: male, female, male, male, and female. Now, when you do one hot encoding of this, then it will be encoded like as it is shown in the lower part. Okay, so that means it will be encoded as I have shown by this brown colored bubble this way. So it shows that originally this column was there, gender, right? This is that column, very first column. But now two columns will be added: male yes, female yes, like that. And if the gender column had male, then male yes will have y or yes value, and female yes will have n or no value, where yes internally will be stored as 1 and no internally will be stored as 0. So that means whether it looks like yes and no here in the output, but it will be stored as 0, 1. Similarly, this is 0, this is 1. Anytime y is there, that is 1, and anytime no is there, that is 0. So that means original the values of the gender, they will be encoded into numbers using this kind of simple method. Okay, this is what is called one hot encoding. Now here what is there? Male, original value was male, so therefore male yes column has now 1 and female yes column has 0, because the person is not a female. Original column value is female, so male yes column has 0, but female yes column has 1 because the person is a female, and so on for the all other 3 rows. Now once it is converted into these 2 columns, then you can either choose to drop the original column, or you can choose to keep the original column. Most of the time we would like to drop the original column only, because all the information which this column was giving, that is already converted into this column. So we drop it, and as soon as you drop it, suppose this was the only categorical column in the data, all other were numerical columns. So now you have dropped your categorical column and it has been replaced by 2 numerical columns, and this have value 1001 like that. Now here original column had only 2 categories, male and female. That is why when I drop it and create one hot encoded columns, then as many columns will be added as is the number of categories here in the original column. So here 2 categories were there, so 2 columns were added and 1 column is dropped. So in short, 1 column is now more. Okay, so that means one hot encoding tends to make the data frame wider, or it increases the dimension of the data frame. Okay, and if these had 3 categories, suppose poor, good, and very good, 3 categories are there in this column. Instead of gender, it is suppose performance rating. Then if I remove that column, then there will be 3 columns here. That is poor yes, then good yes, and very good yes, and again 10, 10, etc. They will be added, right? So if there are 5 categories, so 3 columns will be added, 1 will be gone. So 2 more are added. In short, the data frame will become still wider. If there are 10 categories, then 10 columns will be added and 1 will be gone. So 9 more columns will be added. If there are 100 categories, then 100 columns will be added and 1 will be gone. So 99 more columns will be added. And that is the reason why actually it is not very wise to do one hot encoding for this type of case where there are already 862 categories. So you can imagine that 861 new columns will be added as a result, or that is 862 will be added and 1 will be gone, right? So, but anyway, we are at present just demonstrating. So we write pd.get_dummies, and first argument is data frame and second argument is comma separated list of the categorical column which you want to convert it into numerical column. And if I print this, now you can see the reason why I had to set that option. pd.set option display dot max underscore columns and comma none, because otherwise I would not be able to see this column. Default behavior of Jupyter is to show maybe initial 3-4 column, then just a dot and last 3-4 columns like that. But here now I can see each and every column, and you can see that this is a completely unwieldy way of doing encoding. Though encoding is done, That is clear. That means here true and false are visible. Yes and no are true and false. They are visible, but true is internally stored as 1 and false is internally stored as 0. So that means each of these column is numeric. And you can even check that this head is already displayed, but D types. So df.d types. Now you can see that all these are already, they were already numeric columns, but this column latitude, which was categorical column, now it has been converted into Boolean. Boolean means only two variables, and there are so many columns that this does not display all the column names. It just displays latitude underscore 41.84, latitude underscore 41.86. So that is the this and so on. Okay, and these are all the columns. So it is really very unwieldy. If I try to find the dimension df.shape, then you will see that original compared to original data frame which had only 8 columns, now there are same number of rows, but 869 columns are there. So you can imagine the headache with this kind of data sets if you want to do some further processing. Okay. So what is the output? That's why I said that the rule is that if there are if the output of that n unique which we found somewhere, yeah, here, we first find always n unique or the number of unique categories in the column which we want to encode. And if it is around 5 or at the most 10, you can say, then use one hot encoding, else use another encoding which is called label encoding. Now, label encoding is a better method for this kind of case. But again, if there are less number of columns in a category or less categories, as I said, only 5 categories, then one hot encoding is preferred. If there are multiple categories, then label encoding is preferred. Now, here, import data once again, so that we can start from scratch. So we are importing the data, and this is the head top 5 rows. We can even check the data types because we know that originally all the columns in the data are numeric or floating point number only, float. Okay, this one. Okay, so why it is not changing? df2 it is. That's why it is showing the earlier one hot encoding, but this is df2, right? So each of the data, each of the features, that is a floating point number, right? So now my data frame is df2. So this time also, I just for the sake of demonstration, I will convert a column into categorical and see there is different notation. Earlier I used this notation that df in parenthesis square bracket in the quote latitude, but you can also write the same thing as df2 dot latitude. Okay, so either you write square bracket and in the quote the name of column, or you can just write dot, and then you will get here only. You can write dot and press tab and go on seeing all values with L. Then somewhere you will find that latitude value will be there. Okay, so okay, yeah, okay. So that is latitude. Fine, and you convert that column df2 dot latitude into df2 dot latitude categorical. Here also you are adding one new column, so that original latitude column, okay, will remain as a floating point, but you are adding one latitude categorical. There is no attribute latitude. Why? I think that, oh, latitude I have written, sorry. Okay, yes. So now you can see that the original latitude is already there. It is a floating point number, but latitude categorical is also there. And if you now check df2.d type, then you will see that there is one categorical column, right? So that is original latitude is still floating point. These are all original columns, and this is a new column which you have added. Now, as I said that this is looking like a strange example because we are converting a numeric column into categorical, and that now we are using encoding to convert it back to numeric. But that is because here my data set has no categorical column right from the beginning. But as I said, there can be categorical column like, for example, age, gender, age in the form of bins, then gender, then performance rating like very good, etc., or user's response. Okay, so at that time, if there are categorical columns, then you can convert it like this way using label encoding. Okay, once again, before doing conversion, it is always a good habit to check how many categories are there. So we as such here know already that there are 862 categories, but once again, so it looks that this is a fit case for label encoding because one hot encoding gives a very large number of columns for this kind of case. So we import label encoder from sklearn.preprocessing. So here we are in this stage of our data science lifecycle, feature engineering. We have not yet started model building and all that. So everything in the feature engineering, that is checking for dummy duplicate, checking for nulls, then duplicates, then zero values, and all that thing, everything can be done using this library, that is sklearn.preprocessing, right? So from sklearn.preprocessing, you can import different things. So here I am importing label encoder. Now these steps will remain the same. Similarly, that the pd.get dummies, that step will also remain the same, irrespective of you are doing X dataset or Y dataset or whatever. So please remember this syntax: pd.get dummies, name of the data frame as the first argument, and comma separated list of categorical variable as the second argument. Similarly, here also for label encoding, these steps remain same. From sklearn.preprocessing, you import your label encoder and then create a label encoder in object. But this is just an empty object. LE is equal to label encoder. Now you use that label encoder on the categorical column which you want to convert into numeric column. So you are right, df2 latitude categorical is equal to le.fit transform. Okay, that is the label encoder object which you created in the previous line, dot fit underscore transform, and again same column. So you can see you are not adding a new column. In fact, this column, which is a categorical column, that itself is taken as the argument to le.fit transform, and the result is saved back in that same column only. So no new column will be added. Let us display the output and you will see that there are still the same number of columns. Here you can see 1, 2, 3, 4, 5, 6, 7, 8 and latitude categorical 9. And here also it is 1, 2 up to 9. Okay. So it is the same thing, but now these categories are assigned a certain number. And for example, if you see these last three observations, 37.85, right? So they all have same, they all should be assigned same number because they are one category. So they are 512. Similarly, if I write one more output just for the sake of df2.tail, then in the tail there would be 670 in the two observations, second last observation and the third last observation. Then afterwards, after doing your label encoding also, no, this is already after doing the label encoding. Okay, somewhere here I should have shown here. Okay, so df2.tail. So this shows that second last and the third last, they have the same latitude, 39.43, 39.43. All others have different latitude. So when you do encoding and thereafter if you see the tail, then also the latitude categorical has same category, 670 and 670. It will create as many categories as are the number of unique categories. But the advantage with label encoding is that your data frame does not become too wide. Okay, or in simple language, your model will not become very complex and chances of overfitting, etc. will be less, right? So this is about data transformation, and we have done two things only. One is creating new features by addition, by multiplication, then by doing product of a feature with itself, that is creating a polynomial feature right here. And similarly, we did encoding method. If you want to do one hot encoding, usually it should be preferred only for that categorical column where the number of unique categories are 5 around, or maybe at the most 10, and the one hot encoding is done by one simple syntax, that pd.get underscore dummies and name of the data frame and comma separated list of all the columns which you want to convert from categorical to numerical. Okay, so that is one hot encoding. And similarly, in the label encoding from sklearn.preprocessing, you will import label encoder and create a label encoder object, say le, and then you will use le.fit underscore transform. Always read from right to left. So le.fit underscore transform in bracket the column which you want to take, right? Here also, if you want to take multiple columns, then you can write a comma separated list, but each time you will have to write df2, right? df2, then the second column, then comma, again df2, then the third column, and so on, right? So that will give me the encoded column le.fit transform, and you save it in the same column. Okay, so that is how you can do the label encoding. And the difference between the two also I have shown, that in one hot encoding, the total number of columns increases very highly, and therefore it is suitable only for those categorical columns which have around 5 categories, while in label encoding the number of columns remains the same, because here one column seems to be increased, that is the latitude categorical, but once latitude is converted into categorical, then you have to drop the latitude column because it is already included in the, its information is already included in the original data set, right? In the new data set, new encoded column. Okay, so this is what is that about. And once you convert, then you can always check the data set that you have converted into categorical column, and now you are converting it back to numeric column, right? So this latitude categorical you have obtained. Thereafter, this latitude column is not required. And now, if you check the data type, then you will see that all columns would be numerical. Okay, that latitude categorical, that becomes integer column, and all others are floating point. So this type of data frame can be used with any machine learning algorithm whose features are in the numeric format. Now in next we will do this part, data scaling and normalization. But as I said, in that there is some discussion which will be a kind of revision, standard scaling and all that, but we will do it still thoroughly only. Okay, and one that this L2 normalization, that will require some explanation, right? Okay, so we will stop at this point and we'll see in lecture 3.